Okay, so let's get going. So we start off looking at average rate of change. Remember, that's essentially just the slope formula. You just have to figure out what the y values are first. So for number 1 here, we want to find the ARC of f of x equals x squared plus 7x on 1 to 3. So start with f of 3. That's 3 squared plus 7 times 3, which is 30. And f of 1, which is 1 squared plus 7 times 1, which is 8. So then you do the slope formula. So your slope formula is 30 minus 8 divided by 3 minus 1, which is 22 over 2, which comes out to 11. So number 2 is exactly the same. You just have to, there's some decimals involved, and you want to give a decimal approximation. So we'll skip over number 2 and move on to number 3. Number 3 is not hard because they tell you it's a continuous function. And when you're doing the limit, the limit of a continuous function, that's all you have to do is plug in the point. So literally, that's all we're doing is plugging in 1. So we get 6e to the first minus 4, which is 6e minus 4. And they want 3 decimal places. So we have to go grab the calculator. Then plug this in. And I'm getting 12.31. So just a review on rounding real quick. 12.3096. So you have to look at the 4th decimal place when you're rounding to 3. And because this is bigger than 5, that means we round up. So add 1 to 9. This bumps this up to 12.310. So rounded. That looks funny. That's not a good abbreviation. Rounded to 3 places. Okay, let's look at number 4. Number 4 for the domain, that's all we need to realize is that x is not allowed to be 6 because that would cause there to be a 0 in the denominator. So our domain is the 4th choice x such that x is not 6. The limit as x approaches 1, well, it's continuous on that part, so you can just plug in 1 there. So f of 1 is going to be the same thing as the limit, which is 1 squared minus 36. So this is for part B over 1 minus 6, which is negative 35 over negative 5, or 7. For part C, we actually have to factor it. So x squared minus 36 over x minus 6. We need to do a difference of squares on top so we could cancel out that x minus 6 in order to evaluate the limit. So the limit is x approaches 6 will just be 6 plus 6, which gives us 12. All right. Number 5 is very similar to number 4. You just need to factor. So we'll skip that one and we'll do number 6 because the factoring looks a little more difficult. So for number 6, T squared minus 64 over 2t squared plus 17t plus 8. Top is the difference of squares. T minus 8 times t plus 8. And the bottom, you want to factor by grouping, but I'm just going to do it mentally. So plus 8 plus 1. So essentially, I can cancel my t plus 8s here. It's a little bit easier because you know that likely something is going to cancel, so that allows you to really test your factors more quickly. So then the limit as t goes to minus 8, we get minus 8 over 2 times minus 8 plus 1, which is minus 16 over minus 15, which should just come out to 16 over 15. There we go. Number 7 and 8, we've done one of each of these in both lectures so far, but we'll go ahead and do it again. Number 7, remember what we have here is we have a multiply by the conjugate type of scenario. So as we're doing the limit as h approaches 0 of the square root of 9 plus h minus 3 over h, what we multiply by is the conjugate, so 9 plus h plus 3 over square root of 9 plus h plus 3. So we get the limit as h approaches 0 of 9 plus h minus 9 over h times square root 9 plus h plus 3. So this is the limit as h approaches 0. The 9's cancel on top, so you just have h over h square root 9 plus h plus 3. Those h's cancel. Now we can plug in 0 for the one remaining h, so we get 1 over the square root of 9 plus 3, which is 1 over 3 plus 3, or 1/6. Excuse me. All right. Let's look at number 8 as well. And then from there, we move on to the derivative. So limit as x approaches minus 9 of 1 over 9 plus 1 over x over 9 plus x. Well, we just want to get a common denominator. So the first limit multiplied by x over x, so you get x over 9x. And then the second term multiplied by 9 over 9, so you get 9 over 9x over 9 plus x. So we have the limit as x goes to minus 9 of x plus 9 over 9x over x plus 9. And again, the best way to think about that is two fractions like this, and you're just multiplying by the reciprocal. So we have the limit as x approaches minus 9 of x plus 9 over 9x times 1 over x plus 9. So we have the limit as x goes to minus 9 of 1 over 9x, and we can just plug in our minus 9, so it's going to come out to minus 1 over 81. Good. Okay, you can see someone asked me a question at the end of last class about number 9. So I did the first part already, but really we're just doing the derivative shortcut. So for number 9, we have f of x is 3 minus 4x plus 2x squared. So f prime of x would have been minus 4 plus 4x. So if they ask for f prime of a, that's all that does is switch the letter from x to a. So it'd be minus 4 plus 4a. So that's how we got part A. What's the instantaneous rate of change? Well, instantaneous rate of change is just code for derivative. So for part B, you're just plugging in 6. So f prime of 6 would be minus 4 plus 4 times 6, which is 24 minus 4. So that comes out to 20. And then what is the slope of the graph tangent to the point negative 451? Well, when you have the derivative, that's giving you the slope when you plug in the x value. So for part C, you just need to plug in that x value, negative 4. So f prime of 4, negative 4. Is minus 4 plus 4 times minus 4. So that's negative 16 and minus 4, negative 20.
I just had a question. Why are you getting rid of the 3's?
The derivative of a constant on its own is 0. That was the
So what does that 3 mean initially?
This is the function, right?
Yeah.
So f of x is given by 3 minus 4x plus 2x squared. That would be, say, the y-intercept of that function.
Okay.
Then when you take the derivative of any constant on its own goes to 0. So it vanishes.
Oh, because it's like for a specific point.
No, it's just the rule for taking the derivative.
Okay.
So if we looked at the shortcuts from last time, we did lots of examples of them. So the two special cases of rule number 1, the derivative of a constant c is 0, and the derivative of just something with an x becomes that something. So if we looked at, say, part B, our second example, the square root of 7 is a constant. That's why when you take the derivative, it becomes 0.
Okay. So any constant is 0 when you
Any constant on its own. If a constant's multiplied by x, you take the derivative of the thing it's being differentiated with respect to and then multiply it back. That's
Okay.
17 you could say is a constant, but it's being multiplied by x to the 4th.
So like a standalone constant.
Sure.
All right. Thank you.
Mm-hmm. Okay. So you're going to see something similar here for number 10. So yeah, we'll do 10 and skip 11. They're both we're just using shortcuts here. These should be very short and sweet. You just need to pay attention to the rules. So g of t is 2 times t squared plus 3. So we take the derivative, again, of each part. So the derivative of t squared would be 2t. 2 times 2t makes 4t. And then the derivative of the 3 is just 0. So that goes away. So that's basically part B. It would be for A. They're using t instead of a. So, and then when you're doing g prime of 8, you just change t to 8. So that comes out to 32. Right, so simple enough. Number 11, just take the derivative. So pretty straightforward there. Number 12 and 13, we're going to follow the same rules, but we just have to switch to the exponent notation. So we have b of p is 7 divided by p. So we want to rewrite that using the exponent notation. So this would be the same as 7 times p to the negative first. Whenever you want to use that power rule, you have to write the variable and what power it's raised to. You can't have it somewhere else. So then when you take the derivative, you bring down that negative 1 and multiply it in front. So we get negative 7 and then subtract 1 from it. Minus 1 is negative 2. So you get negative 7p to the negative second. Same deal with 13. We just have to realize that the square root means the 1/2 power. So y equals the square root of x is the same thing as x to the 1/2 power. So if you want to figure out y prime, we do 1/2 x to the 1/2 minus 1, which is 1/2 x to the minus 1/2 power. Okay, number 14. Find the derivative. We just found the derivative of the square root of x, so that makes number 14 a whole lot easier. The derivative of 8x will just be 8. And then we just figured out the derivative of the square root of x is 1/2 x to the minus 1/2. So we have the derivative pretty much right away. The domain of the function, well, 8x is defined everywhere, but the square root of x, so domain of f of x, remember the square root is only legal for 0 and positive values. Once you take the square root of a negative, you get numbers that are not real, and we're just studying calculus of real numbers. So our domain of f of x is going to be 0 to positive infinity. The second part asks about the domain of f prime of x. Now the thing about f prime of x is f prime of x can be rewritten 8 plus 1 over 2 square root x. So it's very similar because you have a square root, so you can't have any negative numbers, but you also can't have 0, because if you had 0, you would get 1 divided by 0, which is undefined. So for that reason, the domain of f prime of x is slightly different. We don't include 0. So that's going to be 0 to infinity. So you just change the grouping symbols. So we'd have 0 to, I think you got to go over here for symbols, infinity. And then we want to change that to a parentheses. And then this one we go 0 to infinity. Correct symbol there. Oh. And it looks like 14 is the last one. So very similar type of problem here. We have g of t is 3 over the square root of t, but we want to think about that as 3 times t to the negative 1/2 power. So when we take the derivative g prime of t, this is going to be 3 times minus 1/2 times t to the minus 1/2 minus 1. So we get negative 3 over 2 times t to the negative 3 over 2, which again, if you wanted to use radical notation, would be negative 3 over 2 the square root of t to the third power. But to me, it looks like the domain is going to be the same for this one because, again, t can't be 0 because it's in the denominator, and t can also not be 0 because it's in the denominator here. So let's go ahead and do the first one, typing in the derivative. And then the domain should be the same for both. It should be 0 to infinity. Yep. Okay, so that is it on the homework. Are there any other questions? So go ahead and stop the recording. Finish this message.